Hello, welcome back to Java for Beginners. In this video, we're going to discuss conditional statements, the if statement, the if else, and the switch statement. So if this sounds like fun, continue watching.
So the programs that we've seen so far would have a very linear straight line execution to them. So we start at the beginning of the scope, and then we find our first statement, the second, third, fourth, and then we find nothing. So we end the program. Correct? That's a very linear execution. There's no conditions in that execution. There's no evaluation of what to do if or. So if we introduce conditions, then our linear execution becomes starts evaluating conditions that we may have in the code and decides to go either right or left, as in it will take this path or this path. And maybe it will take this path over here, and then it will evaluate another condition, or this path will evaluate another condition, and each will have its own yes or no, or true or false. So for conditional logic, the way it usually works is you first evaluate a test, and you get either true or false based on the evaluation of that test. So we can say something like, if x is greater than 10, that is a test. We evaluate that test, say the value of x is 15. 15 is greater than 10. So the outcome of that evaluation is going to be true. And based on the outcome, whether it's true or false, we'll perform an action or a set of actions that are related to each outcome, that are assigned to each outcome. We've spoken about and seen examples of relational operators earlier on in the course. So feel free to pause the video and have a look at this refresher. So for conditional logic, we're going to first talk about if-else statements. So I'm going to start by typing the keyword if, and I'm going to follow it by parentheses, opening and closing parentheses. And then I'm going to start by typing an opening curly brace and closing curly brace. And I'm going to enter in the middle. And here goes a condition, a test that we're going to evaluate. So I've this variable here, an integer variable called number. And I'd like to be able to evaluate whether number is a positive or a negative number. So what I'm going to do is I'm going to say if number is greater than 0, then I'm going to execute whatever between those curly braces, that block. So I'm going to add a print statement and exactly read my thoughts. Number is a positive number. So I'm going to hit run now and see what's going to be executed. So see 5 is a positive number is being printed. All right. Now, what if I would like to print if 5 is a negative number? What do I do? Well, I can come here and I can do if number is less than 0, then I'm going to S out number is a negative number. So I get 5 is a positive number. If I change that to -5 and hit run, I get -5 is a negative number. Great. Now, while this works and it's pretty good, how can we improve it a little bit more? So what is happening here is I'm defining a variable called number, giving it a value, and then I'm executing this test. This test is false, is returning false. So this block is not being executed. And then I come down to this if statement and I'm executing this test. This test is true. And then this is getting executed. Turns out there is a way to reduce that code by merging the two into one block or one if-else statement. So how do you do that? Right after the end of the first if statement, I'm going to add the keyword else. And I'm going to add a curly brace opening, curly brace closing. And I'm going to S out number is not a positive number. And I'm not saying it's a negative number, and I'll tell you why, but it's not a positive number. So basically, if this condition evaluates to false, then it's going to print this one here. So let's see that in action. So I've got -5. So this is definitely, number is not definitely greater than 0. So this is not going to be executed. However, because this is false, then it should execute this block. Let's run and find out. So I got -5 is not a positive number, and I got -5 is a negative number. Now, what's the reason for saying is not a negative? Like, why didn't I just say is a negative number here? I mean, it seems to have to make sense. If it's not positive, then it must be negative. Well, here's the trick. What if I assign 0 here? So I'm going to keep this the way it was, is not a positive number. And I'm going to hit run. Notice that for 0, 0 is not positive, 0 is not negative, 0 is neutral. So when I had my condition here, number is greater than 0, that evaluated to false. So that was never executed. However, this was executed because it's the opposite to the condition that failed. So in the case of 0, which is an edge case here, it is correct to say that 0 is not a positive number, but it would be incorrect to say 0 is a negative number, because look at the test for negative number here. It didn't pass that test. Is 0 less than 0? No. So this was not executed. So what if I want to still merge the positive and the negative into one if-else statement? However, I don't want to make the mistake of counting the 0 as either positive or negative. Well, I can add an if. So else if, as in execute this condition and check if it's true. If it's true, execute this guy and move on with your life on to the next one. But if this is false, then I'd like you to come here. So when this was before else, then we said, okay, so when this is false, execute this no matter what. No, I'm gonna add an extra condition here. I'm gonna say else if, and I'm going to say number is less than 0. Then I'm going to execute this. I'm gonna get rid of this for now, and I'm gonna change it back into 5, hit run. I get 5 as a positive number. If I change it back to -5 and I hit run, I get -5 is a negative number. That's great. What if I change it to 0? What will happen? I get nothing printed because obviously this condition was not met. This condition was not met, so nothing is being printed. So what I can do actually is I can add another else, and I can have an S out in there, and I say number is a 0 number. Well, we could just say is 0. And if I hit run, I get 0 is 0, or the number that we have selected does not lie in this range, or this range, which is the positive numbers range, or the negative numbers range. I hope that makes sense. One note here. So you can add as many, like these, you can chain them. So like you can have as many else if as you like. Like I can have another else if in here. Number equals 0, for instance, and that'll work. Although in this case, it's either bigger than 0 or like greater than 0, less than 0, or it'll have to be just 0. Otherwise, like this check right here is redundant, but we could still add it and we can hit run. It wouldn't be efficient because you're performing an extra operation that is redundant. You don't really need it. But it's there if you like. So as it turns out, you can have as many else ifs as you like chained in one if statement, basically if else statement. So I've an if here with a condition. If that's true, I'm executing grade is A, and then I'm moving on to the next thing, which could be like an if statement just printing out the score. So if I hit run, I get grade is B. Because see, let's change it to 95 just to demonstrate the idea. So I get grade is A, and I've got score 95. None of this other things get printed. So we've seen this before, but now on a bigger scale. If score is not greater or equal 90, so let's change it back to 85, then only when this is false, you move on to the very next one. So this one, not this, and not the else. And then you check the validity of this test. And if this test is true, then you get grade is B. And then if you change that to 75, then you get grade C. And if you change it to 65, you get grade D. And then basically, if you're not greater or equal to 60, like 59, then you basically failed. So 59, we hit run, and we get grade is F. Now, of course, this is not by any means a complete application, because like, you can have a grade of a huge number, and that'll be A. But maybe your application should check if the grade is greater than 100, and then say you've submitted a wrong grade. So how do we do this? Well, we could say if grade score is greater than 100, then you want to S out your score is higher than 100, which it shouldn't be the case. And now, with the power of else, this becomes an else if. So first, I'm checking if the score is greater than 100, and that's not a correct score. So your score is greater than 100, which is incorrect. And if I hit run, instead of getting grade A, I'm getting the correct response, which is a validation check. But what if the score is less than 0? That's also an incorrect score. So let's check for that. So score can't be negative, right? So I'm going to add an else if, and I'm going to check score is less than 0, and put in here S out. Your score is lower than 0, which is incorrect. And I'm going to bring this up. And now my F statement for checking the scores actually has validation, in which case if you try to submit a score that is inaccurate, so it doesn't lie between 100 and 0, with 0 and 100 included, then let's say -1, then I get the correct validation statement printed. Isn't that cool? So that's your if else with very basic conditions that we're having here. Later on, we're going to look at much more complicated conditions, because basically what goes in between those parentheses is an expression that has to evaluate to either true or false, so that we know where to go, here or on to the next one. So this is a very basic one. We can have a compound expression, and we're going to get into those in a bit. All right, so continuing on for our example here, what if inside your if statement you had an if statement that had an if statement inside? Is that possible? The answer is yes, and this is called nested if statements. Let me refactor the code that we had here. Yeah, but what I'm going to do is I'm going to keep this part, the original part that we had. Yeah. So I'm going to paste that into an if block. So if score is greater than 90, all the way down till score is greater than 60, and otherwise it's F. And we're going to handle the validation not as part of this if statement, but outside. So we're going to handle the validation here. So we're going to say if the condition that we had here, score is greater than 100, then else if, and then here else. And I'm going to copy this score less than 0 and paste it here. And so now we got our code cleaned up. So let's have a look again. So if score is greater than 100, then this is printed. Then you move on to the next condition. Else if score is less than 0, then you print this. So higher than, lower than, and then else, which I'm pretty sure in this case, if it's not greater than 100 or not lower than 0, then it's between 0 and 100, with 0 included and 100 included, because these are not greater than equal, less than equal. So the case 0, 1, 2, 3, 4, 5, 6, etc. until 100, of integers are all included here, and we can then execute our original logic. And if I hit run, I'm going to get your score is lower than 0. And if I make the score more than 100 and I hit run, I get it's higher. And if I make it within, like, I don't know, 100, then I'm going to get the grade is A. Makes sense. Now, for these conditions that we have here, so we have those two conditions over here. Can we combine them into one condition or one compound condition, let's say, or an expression? The answer is yes. So I'd like to transform this portion, rewrite it. So let's just go ahead and do that. So I'm going to write if score is greater than 100 or score is less than 0, then I'm going to print you did not enter a valid number. That a valid grade, let's say. Yeah. And then in the else, I'm going to have our original logic here to determine the grade. And so we've made the code a little bit shorter by combining the logic. And then remember how OR works. Like if this is true and this is false, or this is true and this is false, or both are true, then the expression will evaluate to true. Now, obviously, a number cannot be less than 0 and greater than 100. So in this case, you either have this true or this true. And only if both are false, then we're going to have false evaluated here and then move on to the else block. So if I run this again, I'm going to get the grade is A. And if I make the number ridiculously large, then I'm going to get you did not enter a valid grade. Same goes for a negative number. Let's look at more examples. I've got an integer number equals 7. And then that number, we're calculating whether there is any remainder when we're dividing it by 2. If that's the case, then it's an odd number. If it's not, then it's divisible by 2, and it's an even number. And so if that actually evaluates to 0, what we do is we take that value and we say, is that value equal to 0? And then that's going to be printed here, which is the case when it's even or when it's odd. So if I hit run, I get the number is odd because it's 7. If I change it to 8 and sorry about that, hit run, I get the number is even. Another example here, which is maybe a little bit tricky, but bear with me. So we've a character called letter, and we're assigning to it the value A, right? And so remember there were 3 ways from earlier where when we talked about character primitive data type, 3 ways to assign a value to a letter, to a character. The first one would be the character literal itself, which is in this case what we're using, or it could be the Unicode or the decimal value of that Unicode. So in this case here, we're just using the literal, and we're performing basically 2 comparisons here. So we're making sure that the value of letter is more than A. So this will be implicitly transformed into an integer. Like, do you remember implicit casting? So an implicit casting will happen here, changing it to its decimal value. Remember, you could use the decimal representation of the Unicode to assign a value to it. So going back to the Unicode table that we've seen from earlier, A is at 65, B at 66, capital A and capital B. So all the uppercase letters are from 65 all the way till 90. And A, starting for the lowercase, starting from A, that's 97 all the way down to 122. So if you actually replace this with 65 and this with, I forget what the other number was, then it makes no difference because that's actually what's happening. These numbers are being converted into their decimal representation. And this number is, or this letter actually is being transformed into a decimal representation, making it just a matter of comparing numbers. So if you hit run, you get that the letter is uppercase. I will say something though. this code isn't entirely accurate. Because, like I said, going back to the grade problem, if you have a number that is higher than 100 or lower than 0, then you run into all sorts of problems. So here, we can actually make this accurate by, and we call that in software development, fixing the bug, because this is clearly a bug. Like you could have other types of characters that are not letters, and they will show up here, basically, and it will state that they are lowercase. So what we can have is the same thing here. Well, instead of using capital letters, we can use small letters. And now, if we run this, we get this letter is uppercase. If I choose a lowercase letter, it will tell me it's lowercase. And if I put in there, I don't know, like a $sign, and I hit run, then nothing is going to be printed. Whereas before, it would have printed that the $sign is a lowercase number or lowercase letter. One last note about if statements. It turns out that these curly braces here are optional if the content within the curly braces is only one statement. So in which case, we consider the if statement that we have here. If number is greater than 0, else if number is less than 0. So if it's greater, I'm printing it's positive. If it's less, I'm printing it's negative. And then I'm printing consider changing the number to a positive number, just to have more than one print statement in a curly brace block. So I'm going to hit run. For 5, I'm getting it's a positive. For -5, I'm getting it's a negative, and consider changing it. So I'm going to get rid of the curly braces for the if block and leave the curly braces on the else block the way they are. And I'm going to hit run. Everything works as you would expect. Cool. However, if I, like I said before, there has to be only one statement in there. So if you change that and get rid of the curly braces, no compilation error is going to happen whatsoever. But however, like if you run the application now, notice what was printed when I had the 2 curly braces and the number was positive. I'm going to run it again and I get number 5 is positive. Consider changing the number to a positive number. So why is this happening? I'm going to make it easier to detect now when I reformat the code. So on Mac, it's Command L. I'm going to reformat and then look what happened. So this print statement is no longer part of the if else. Why? Because like I said before, if there is no curly braces after if or after else or else if, then the if statement is going to consider the first line as the thing that should be executed, and that's it, in the case of the if being true. And then going here, it's going to consider the first statement to be the thing that it needs to execute. And then this is going to be kicked out of the else. It's going to be outside of that scope. So this is going to be executed no matter what happens here. Like I can pass 0, right? And 0 will not be greater than 0 or less than 0. And if I hit run, I get this statement only printed. Now, what happens if the first part had 2 statements? So I'm going to bring back the curly braces. All right. I'm going to refactor the code, reformat the code. I'm going to add another statement. It's going to be hello world. If I hit run, I'll change that to a positive number. I'll get hello world printed. What if I wanted to get rid of the curly braces here? Now I have more than one statement. So watch what's going to happen. If I try to run, it's going to say else without an if. Why is that? Well, as it turns out, if I reformat the code, it'll become a little bit easier to follow. These here are now a block, and that's it. There's no else. So as far as the compiler is concerned, I have an if, and I have a statement to be executed right after, and then that if business is done. Now I have a floating outside of the if, print hello world, and oops, there is an else Where the heck did that come from? Where's the if for it? There's no if for it. So the way to fix it is to add the curly braces here, or is to just get rid of the else, and then that becomes its own if statement. So that is the use of curly braces in if-else blocks. So more about if statements. Let's talk about conditional assignment. So I've got number 1 and number 2, and I want to compute the max of the two and the minimum of the two. So one way to do that is to say if num2 is greater than num1, if that's the case, then max is num2 and min is num1, right? And I could do else. So max would be number 1 and min would be number 2. And so if I print max and then print min, I'll get 8 printed first, then 7. Now that works perfectly fine. I've changed the values and made this to be the minimum and the other to be the maximum, and I get the results printed. Now that's all great, but is there a better way of doing this? Is there a way to get rid of those if statements? And the answer is yes, if we use conditional assignment. So conditional assignment works as follows. So I'll use the same statement for the declaration of max and assigning a value to it. And the way you do conditional assignment is you have a condition, and if the condition is true, you assign one value. If the condition is false, you assign the other value. So my condition is going to be num1 greater than num2. That's a condition. You follow it by a question mark. And then the first thing you have there is the value you're assigning if the condition is true. So if num1 is greater than num2, then the max would be num1, right? Now you add a colon after, and then you say, well, if num1 is not greater than num2, then num2 is greater than num1. So you add num2. Makes sense? And then we could do the same for minimum. So I'll go here and I will go num1 is less than num2, right? So I'll assign, well, the autocomplete got it wrong. So if num1 is less than num2, then num1 is the minimum. Otherwise, it's num2. So see here, I can get rid of that block. And if I run the code again, I'll get the same outcome. If I change this to be the bigger number and I run again, I'll get 9, then 7. That's conditional assignment. Last bit of conditional logic that I want to talk about for now is a switch statement. So I'm going to begin by defining a character, and that character I'm going to call grade equals, and let's just give it a value of A. This could be A, B, C, D, all the way through to F. And I'm going to type in switch, and it's auto-completing for me grade. So you need a pair of parentheses and a pair of block curly braces, basically. And in there, I'm going to type grade, which is the variable that I'm going to be considering for this switch statement. And basically, in the switch statements, I'm going to define cases now. And in each case, you perform a certain action that corresponds to a value that grade may store. So I'm going to define case A. It's auto-completing for me. So case, if the value of grade is A, a colon, and then I'm going to move on to the next line, and I'll just go with whatever it's suggesting. So you are A, or let's say, well done. All right. And you see, it's suggesting to me that I should type in break. So I'll just go with that, and we're going to talk about break in a bit. So just keep it in the back of your mind. So I'm going to go with case B now, and I'm going to print, well, good job scoring B, and I'm going to break, and I'm going to define case C, and then S out, good scoring C, and I'm going to break, and then let's just leave it at there and see what's going to happen. So I'm going to hit run, and I see that I got well done scoring A. So what essentially happened here is I've got a value here, that's A. So I get to the switch statement. Oh, I'm switching based off the value of grade. In the case that it's A, print this and then break. Now break is essential because it tells the switch statement that you should just break out of the switch statement. And if you remove it, then, well, before I remove it, let's change the value to B and see what's going to happen. I got good job scoring B. Well, what if you change it to D, which isn't defined here? What's going to happen? I get nothing. I get nothing printed because there's no case defined for D. So let's talk about what happens if you remove the break. Removing the break is necessary. You should remember to type it, unless you don't want to type it for like very specific reasons. But most cases you want to type it, because if you don't have it, what's going to happen is, well, we're going to change this to A and hit run. And you see that it executed well done scoring A, but it also executed the B, right? So the idea here is once it hits the case, it will execute everything after until, so it will ignore any case statement after. It will just go and execute everything until it runs into a break. So if the break is here, then that's great. But if there's no break here, and then there is no break here, then it's just going to execute everything in its way, which you don't obviously want that. So what happens when you have D, right? It will not execute anything. So what if we had a case for everything else? Like, do you remember how we had if, else, if, else, if, and then else? Well, we could have a case that is equivalent to else, which is everything else, called the default. So default, I'm gonna print, I don't know this score or grade, and break is optional. And I'll show you why. So I got here, I don't know this grade. So whenever you're dealing with the last case, in which case now it's the default, but it could have been the case C, then break is optional. You can have it or you don't have to have it. See, the rule is once you hit a case that matches the value in grade, then let's say it's case C, then you're gonna continue executing until you hit break or you hit the end of your switch statement. So if you're at the default case, which is always going to be the very last case, like if you try to put it ahead, it's going to complain that default branch not last case in switch statement. So it needs to always be at the end. So having a break for it is quite pointless because, well, the break is already here. But say if you didn't have default at the end, which is optional, then having a break for case C is going to be optional, seeing it's the last case. So basically the equivalent code for this would have looked something like this. If grade equal A, then you want to print this, and you want to go else if, okay, and then you want to repeat the same for C. And then for default, you just go else, and that's your default. And if you comment this out and run the application again, you get the same outcome. So using the switch format for this very specific type of if statement with like nested ifs, well, this looks a lot cleaner. You just always remember to have the break because you run in the risk of forgetting the break and then executing the logic. So it's like running the risk of executing this statement when you're here. Like that never happens in an if statement because you have the curly braces and they're enough. However, here, just always remember to have the break. Let me show you another example here for switch. So I have an integer month equals 5, and depending on the month of the year, I'm printing the name of the month, depending on the number. And of course, there's no 13th or 14th or 15th or minus 5 month. So any value that does not match those values will say invalid month. And you basically just execute and you get May printed for 5. I'm gonna change it to January since we're in January as of recording this video, and I get January printed. We've seen how we could use the switch with the character, and now we're using it with integer. Although, one note here, do you remember from earlier when we talked about if you know that your number is going to be from minus 127, 128 till positive 127, then you may as well just use byte, correct? So that's one case of when you're sure that there's no value, like there's no logical value for a month that should exceed 12, then just using a byte is fine. And if you hit run, then you get January printed just as before. I could also use short. I'm not going to be able to use long. So if I try to use long, I'm going to get an error message. And basically, if you read it, it says found long but required. So from the primitive data types, I can use character as we've done before, byte, short, integer. Those three, byte, short, integer, you can store whole numbers in them. And then the rest of those types we haven't talked about before, so I wouldn't really worry about them for now. But yeah, feel free to experiment with character, byte, short, and integer. Make your own switch statements and see how that logic works.
Thank you for watching. Hope you found it useful. And if you have, give us a thumbs up and hope to see you in the next video. Bye-bye.